Hello everyone and welcome back again. In the previous session we stopped at this point of calculating the target main strength, which is the characteristic strength plus the margin. The margin is the constant k time the standard deviation, and we have learned that if we don't get the standard deviation value in the question, then we go and find or determine it through the figures. And today we will continue until the end of this section, the first stage. So the first stage, as we mentioned before, at each stage we need to determine something related to the mix design. For the first stage here up to here, we need to, at the end of this stage, we need to calculate the target main strength that we already calculated before, and also we need to determine the water to cement ratio. So at the end of this stage, we will come out with the water to cement ratio for our mix design. So determine the water cement ratio. We'll go step by step. We already stop here. We'll continue. Here, 1.5, section 1.5, the cement strength class. As we mentioned before, we have two classes of Portland cement. It can be either 42.5 or 52.5. The one we are using, as mentioned in the question here, that we are using Portland cement class 42.5. So we are selecting 42.5, not 52.5. Okay, here 1.6, the aggregate types, the coarse aggregate and the fine aggregate types. In the question is already giving that we are using coarse aggregate uncrushed, and the fine aggregate it's also uncrushed, so we just select the uncrushed and the uncrushed here. What next? Then we'll start calculating the water cement ratio based on this information that is given in the question. In order to determine the water to cement ratio, we need to start using table 2 and figure 4. So we go back to the figures that is come out with these DOE sheets. So we will go with table 2 and figure 4. This is table 2 and this is figure 4. We will start with table 2. So what is table 2? Here, what type of Portland cement do we have? We are 42.5 type or class of Portland cements. The type of the coarse aggregate is uncrushed, the same as what we have did here. We have 42.5 type of Portland cement, uncrushed and uncrushed of the coarse aggregates. And here is the compressive strength after how many days? After 28 days, right? So we have 42.5 uncrushed at 28 days. So this is the value that we are looking for, 42. So from this table, we come out with the value of 42. What is 42? 42 actually is a compressive strength if we want to use water to cement ratio 0.5. So if we are using water to cement ratio 0.5, using this type or this class of Portland cement and uncrushed aggregate, so we will get compressive strength of 42 megapascal at 28 days. So this table is approximate compressive strength megapascal of concrete mixes made with water to cement ratio is of 0.5. So this is the compressive strength of 0.5 based on the type or the class of cement you use and the source of the aggregate. So this is the first method or the first step for determining the water cement ratio is to get the value here, which is 42 megapascal when we are using 0.5. So then we go and for the figure 4. In order to determine the water to cement ratio here, we use table 2 first, then we go for figure 4. So from table 2, we come out with the value of 42, and we come here for this figure. So what is this figure actually? It is the relationship between the water to cement ratio. This is the water to cement ratio, and this is the compressive strength. So the water cement ratio and the compressive strength. And here is 0.5 is water cement ratio, and we have a compressive strength here. From this table, we come out with a compressive strength of 42. Let's have this one here in more details. This is the first table that we will use, table 2. We're using cement type of 42.5 uncrushed at 28 days. Then we come out with 42 at water cement ratio 0.5. Then we use this figure. This figure is a relationship between the water to cement ratio and the compressive strength. And we need to just use this value and apply it here. We need to use zero point 0.5 water cement ratio and compressive strength of 42. So this is the 0.5. You go up and we need to find the 42. Here is the 42 megapascal and here is the water cement ratio and we get this point. We are getting this point. So we are getting this point. The 42 which was already determined from the table, we go back, and this is the water cement ratio, we come out with this point. Then we start using this point, we start to draw a line similar and parallel to this line that passing through these points, and it will be something similar to this one. So we get this number, which is related to this one, we get the point, then we start to draw the line similar to this one and parallel to this line and passing through this point. And this line will be our reference. We will start using only this line. Then this is the compressive strength as we said from the table, but this is assumed. This is all giving in tables, but we are not designing for 42 megapascal. We actually design for a compressive strength of what? The compressive strength of 46 megapascal, our target main strength. This is our strength that we will use in the calculation, 46 megapascal. Then this is 42 if 0.5, but our target main strength is 46. Then we go from 46 here. This is the 46. We go back, we use our new line, then we go down, we determine our own water to cement ratio. So again, in order to determine the water to cement ratio, we need to follow two steps. The first one, we need to use this table. This table, based on the cement type and based on the type of the coarse aggregate, after how many days? 28 days, then we will get this value, 42 megapascal. 42 megapascal is the compressive strength when we are using water to cement ratio is 0.5. Then we use this value and we apply it here. At 0.5 water cement ratio, the compressive strength is 42. So at 0.5, the compressive strength is 42. So we draw the line here, draw the line here, we get this point. Then we start to draw a line passing through this point, which is similar and parallel to this line. This is how it would be, the hidden red line. Then we start use our own compressive strength, which is 46 megapascal, our target main strength, this value, in order to determine our own water to cement ratio, because this is a relationship between the water to cement ratio and the compressive strength. So 46 megapascal, we go back, we use our new line, and we go down, we get our water to cement ratio. So we go back to the sheet, and we can get the water to cement ratio is 0.47, and here is the maximum water to cement ratio. Here is it's written that the maximum water cement ratio that you can use is 0.55, and since it's below the maximum, so we will use the same value of 0.47. So at the end of this session, we already came out with our water to cement ratio is 0.47. So we stop here. In the following session, we'll start with the following stage or step for DOE method.